The number of deer living in a forest is counted each year. T equals year represents 1990. Please circle that. It's very important that we recognize that. So again, our years is going to be our X, our population is our Y, and in the calculator, L1 column is X, and L2 column is going to be your population. Now here's the key point. If we said year 2, you always have to add this value to 1990 because T equals 0 is 1990. So 1990 plus 2 represents in 1992, this is the population of deer. 1994, population of deer in the forest, and so on. Let's go up right now. Let's go to Stat, go to Edit, and I'm going to plug in the information. 2, 4, 6, and 8. Going back here. And when I previously did this problem, I messed up in plugging in my number. So I'm going to go back as I'm trying to go through this quickly and make sure I did plug it in correctly. Next, I'm going to adjust my window. I want to go slightly below this and slightly above this. So I'm going to go 0 to 10 right now for my X's. I'm going to go 0 to 10 for my X's, and that's going to be the year. And then for population in the Y's, I need to go up to at least 1,000, maybe even a little past it. Let's actually go up to, I don't know, maybe I'll try 1,100. 0 to 1,100. And this is going to be population of deer. All right, so at this time, we're going to go second scatter plot and turn it on since we previously cleared our calculator. Now let's take a look at this. Now I can see this looks like it's going to be a U shape that's trying to kind of go like this. Let's compare to what we talked about in before we did video 1. Let me find those. I got it here somewhere. You guys that are in front of me, look at your, there it is. Okay, so let's compare what I see here to the graphs that I'm given. Remember, it's a shape that's more like this. So I think that's going to represent a logarithmic model. We can see here, it looks like it's going to be right to me. And when we're using this, as Mr. McFarland said, we are going to use the natural log as we do that. Let's see if that works. So on here, we're now going to check. Let's go to Stat, Calculate, and go down to number 9. Number 9 is going to be the natural log regression model. Pressing enter all the way through. All right, now we want to take that and let's put that actually into the calculator. Go up to Y equals. And how do we insert that exactly? We hit bars, we go down to statistics, go across to EQ and press enter. Now, we've already adjusted my window. We should be able to see this. It doesn't mean it's going to go directly through all of the points, right? Because it's like an average of this, as averages as it goes through and creates this model. That looks great. So let's go down to part A of number 2. Part A of number 2, we have this picture here. I do need to write down the equation. That's one of the things that's required. I'm going to press pause and write it in this position right here. Okay, let's go now to this next part. Part A, according to this model, what will be the population of the deer in 2008? So I need to take this 2008. I want to know what is the population. I'm going to box it in. Population is the Y. I don't know the Y. That's what I want to try to achieve. And the X says 2008, but I need to rewrite 2008. I need to write it in terms of the T's. So if I look up above, I can see that T sub 0 is 1990, T sub 2 is 92, T sub 4 is 1994. So what would 2008 go back to? Well, if I take 2008 and I subtract it from this initial year, that's 0, I end up with a value of 18. So this is my X value. This is my X value. So how do I calculate this? I literally take this equation and I'm just going to substitute an 18 in for X. Let's do that together. So I'm going to start with, I think I'm going to start by doing this by type, I think I can do the whole thing. Let's try it. 245.2111312 plus 352.2569969 times the ln, and now my ln is going to be 18. Year 18 represents 2008. I press enter. And this is my answer. And again, I'm trying to figure out, the population. So when we think about deer, this would be 1,263 deer. That's what the estimation is in the year 2008. Okay, let's box in what year. So this time I want to know what is the X value, and I know the Y value is 1500. We'll go back and do the calculator operations later in terms of how can you do this for your AP test quickly. So I want to input in 1500 here. And now this is where, like problem number 1, where I'm just going to round to the nearest tenth as I write it down. But anything I plug into my calculator, I'm going to put in the exact amount. This is just kind of being lazy and saving time. So this is what I have right now. I've inputted in 1500 for the Y value, and I want to solve for X. We're doing PEMDAS backwards. So first we're going to start by adding or subtracting. So I'm going to subtract this amount. But when I plug it into my calculator, I'm not going to do the 0.2. I'm going to write the entire number out. So at this time, I'm going to take 1500, and I'm going to move it down so you can see. I'm going to take 1500, and I'm going to subtract this entire amount, not the rounded number, this entire amount. So 245.2111312. Okay, and as I write it down, this is me being a little bit lazy. I'm just going to round to the nearest tenth. Okay, so I've done the adding and subtracting of PEMDAS. Now I'm going to move up to multiply and divide. I'm going to divide by this number, 352.2, divided by 352.2. Okay, I'm going to use the exact numbers when I actually plug it into the calculator. So we can see if this is the exact number, it's not rounded, and I want to divide by the exact number. So I'm going to take this value and divide by this exact number right here, and I can see it up here. So 352.2569969. Remember that ln is really just the natural log, or ln is really just log base e. So I'm going to write that down. 3.562 equals log base e of x. These are equivalent math statements. If we now want to solve for x, we need to remove log base e. Whatever this value is, I'm going to make it the base, and this becomes the exponent. Whatever you do to the right, you must also do to the left. And in doing so, on the right-hand side, we think canceling out, but really, this is really going to simplify to 1, and I bring down the x. So I'm going to take e to this exact number that I can find on my calculator. Now, how do you find the e function? It shares a button with ln, so I need to hit the blue key and then ln. So blue key and ln, and now I want this exact answer from before. I can do second answer, and this is what I have. So x is 35.23. Let's go back and see what is the question asking for number 2. In what year? I can't say year 35.2. I need to go back to, this is a t value. This is a t value. So if I'm going to change this into an actual year, I add this to the year 1990. So in the year 2025, we can assume the population of deer in this forest was able to reach 1,500. Now, is there a way to do this on the calculator that would be much quicker? Yes, let's do it both ways. So grab your calculator with me right now, please, and we're going to start by doing part A. Again, I want you to know how to do it just calculator related for your AP exam, and then also for the unit exam where you have to show your work. So I have this graph, and I want to know year 18. Now, that's an x value. Before I plug this in, let's look at the windows. X's don't even go out to 18, so let's extend those out to 18. And now I should be able to see this. Let's check. Second trace value, type in 18, and we can see we get the exact answer. Now let's go to part B. Part B provides us a y answer, so let's plug in 1,500. But before I graph it, I'm going to go up to windows, and I can see that the y's don't even go up to 1,500. So let's adjust those to go back or past 1,500. And now let's graph. Okay, eventually they're going to cross. That's what I want to be able to see. Where do they intersect? But I need to move this x value out further. Right now I'm only at 20. I'm going to try going to 30 or 40 and see if that's far enough. Okay, I can see I moved it out to 40. I'm able to see exactly where they cross. Second trace intersect. I press enter 3 times, and we can see we are able to achieve the exact same answer.